Good morning, students. Before going into the disaccharide, we'll see one more property of monosaccharide, which is optical activity. So the optical activity is a special characteristic of the monosaccharides, especially the carbohydrates. So this optical activity is the property of your carbohydrate to rotate the plane of polarized light either to the right or to the left side. So this property, we call it as optical activity, and this property will be exhibited by carbohydrates. So this property is due to the presence of asymmetric carbon atom in the structure of the carbohydrate. So already we have studied about the chiral center. So based on the chiral center's location or based on the number of chiral center, the property of rotating the plane polarized light to the right or left will be obtained by the particular carbohydrate molecule. So the monosaccharides which are having asymmetric carbon atom has the property of optical activity if it possesses the chiral center or chiral carbon atom. The chiral carbon atom is also called as asymmetric carbon atom. So those sugars which are capable of rotating the plane of polarized light to the left, if it rotates the light towards the left, then these sugars are called as levorotatory. So either you will call it as levorotatory or it is denoted by small l or by negative sign. Whereas those sugars which are capable of rotating the plane of polarized light to the right are termed as dextrorotatory sugar. So these dextrorotatory sugar are denoted by small d or positive sign. And most of your glucose and fructose will be rotating the plane of polarized light either to the right or to the left. So based on the rotation either to the right or left, it will be denoted as small l or small d, or plus or minus sign. So there are no relation between your capital D and capital L. So those are all different. Small l and small d represents the optical activity, whereas capital D, capital L will be different based on the hydroxyl group which is present at the fifth position of the carbohydrate. So we have to remember that the optical activity means it will rotate the plane of polarized light either to the left or the right. So based on that, it will be represented as small l or small d, or by means of positive sign or by means of negative sign. So any sugar which may be D sugar, or it can be L sugar, which can also rotate in levorotatory direction. Example, you have D fructose. So it is denoted by capital D, D fructose, but it will rotate the plane of polarized light to the left. So these are all called as levorotatory sugars. So fructose will be levorotatory, though it is designated as D fructose, but it will rotate the plane of polarized light to the left. So it is called as levorotatory sugar. In any solution, glucose is dextrorotatory, and sometimes glucose is also called as dextrose. That is because the glucose is capable of rotating the plane of polarized light towards the right. So since it is capable of rotating the plane of polarized light towards the right when it is present in the solution, the glucose is also called as dextrorotatory sugar. That is why it is also called as dextrose. So nowadays we are using positive sign, negative sign to denote the rotation of plane of polarized light either to the right or left. If it is to the left, it will be denoted in the negative sign. If it is towards the right, we will be denoting with positive sign. So now you can see if ordinary light is passed in the solution, it just vibrates in all the direction. That's why they had put all the direction arrow marks. So it just spreads ordinarily in all the planes. Whereas the plane of polarized light, when you just pass through the solution or pass through any medium, it just vibrates towards only one plane. So you can see only through this plane. If you're passing through this direction, it will be just vibrating only in that particular direction. That is a major property of your plane of polarized light. So now in the solution, if you have glucose, so already we have discussed glucose is a dextrorotatory sugar. So if we have glucose, so glucose can rotate the plane of polarized light towards the right. So you can see it is rotating like this. So the plane of polarized light from the center, it has started moving towards the right side. That is why it is called as dextrorotatory, or it is denoted by plus sign. In case if the solution has fructose, so fructose can rotate the plane of polarized light towards the left. So you can see the arrow mark. This plane of polarized light turns towards the left and it rotates towards the left. Then the particular solution or the particular fructose is designated as levorotatory, and you are denoting it with negative signature or negative sign. So now you can see a pair of enantiomers they have taken. So you can see clockwise rotation as well as counterclockwise rotation or anti-clockwise rotation. So once in the solution, if you mix either here in this beaker, we are mixing dextrorotatory sugar, and in this one, we are mixing levorotatory sugar, and we are just passing the plane of polarized light towards the arrow mark. So this arrow mark denotes they are passing the plane of polarized light in that particular direction. So now what happens, since we have dextrorotatory sugar, it just turns the plane of polarized light towards the right side. So only it is denoted as small d or plus signature. And here in case of your levorotatory, this solution has levorotatory sugar like fructose. So when they pass the plane of polarized light towards this direction, what happens? The particular plane of polarized light is twisted or turned towards the anticlockwise or counterclockwise or the left side. So this particular solution which contains the carbohydrate or monosaccharide will be called as levorotatory, or it is denoted by small l or by means of negative sign. Thank you, students.